Hello, good morning everybody. In this tutorial we are going to make the map and the player movement. Without further delay, let's get started. Create a new tile map scene. Change the name to map and save it. In my case, I will put it in a folder called maps. Now, create a new tile set for the tile map and open it. Load the tile set image. Enable the tile snap option and create a new tile. After that, the snap options drop down appears at the right. Click it and change the step to 8 pixels, since that's the size of the tiles we are using. Now create all the tiles you need. I'm going to pass this part fast because it's very repetitive. Don't forget to add collisions too. We are finished with the tile set. If you want, you can add more tile map nodes for the collisions and platforms. I will not show it in the video because it's the same process as the tile map we just configured. By default, the cells of the tile map have a size of 64 pixels. To be able to place the tiles one at the side of the other, change the size to 8 pixels. With the tiles ready, it's time to start creating the map. But wait a moment, not in this scene. Create a new inherited scene from this scene and create the map in this new scene. This way, we can inherit the map scene every time we want to create a map and we don't have to create the tile maps each time. Okay, so this is the map I made. You can create your own. Instance the map as a child of game scene and play the game. Perfect. Let's move on and make the player. Create a new kinematic 2D scene and change the name to base character. The player will inherit from this class and we will represent the other players with this scene. So in this scene, we will add only the minimum things we need to represent a player. Change the base character collisions. The layer should be player, and the mask, wall and platforms. With this mask, the base character will be able to collide with the tile map and the platforms. Add a sprite node and load the character's texture. Open the animation drop-down and set H frames to 16, since there are 16 columns in the texture. But don't change B frames. We will select the row we want using the region rect. So change the rect width to the width of the texture, 256 in my case, and the height to the height of a row, 16 in my case. In later tutorial, we will change the region rect through code and select the row that contains the character the player selected. Changing the region rect allows us to use the same frames for all the characters. This way, we don't have to create different animations for different characters. Next, add a collision shape to the node and add a shape to it. Add an animation player node. We'll make the animations in a moment. But first, let's add the last node. Add a label to display the name of the character. Move the label at the top of the character. Put some name at the text and center align it. The default font is blurred and ugly, so replace it with some of the Kenny fonts. Go to Theme, Overrides, Fonts, and add a new dynamic font. Click it, go to Font, and load the font you like the most. Now that we have all the nodes, create a script. Add class name base character to make it easy to extend this script. Create a variable for the health points. Let's initialize it to 2 and add a setter. In the setter function, assign the new HP value to HP, and if the HP is less or equal to 0, call the die function. There is no die function yet, so create it. Add pass inside the function. We will implement it later in the player script. create a function called damage with an integer parameter. Inside the function, reduce the HP using this parameter. You have to self to call the setter. We will call this function later from the hitbox. Create two more empty functions. Enable hitbox and disable hitbox. We will implement them in the player script, but we need them now to make the animations in this scene. Finally, create an onReady variable for the sprite. For the moment, we are finished with the script. Let's make the animations. Create an idle, run, and let animations. In the start of the three animations, call the disable hitbox function from the script. Finally, create the attack animation. When the character lowers the sword, call the enable hitbox function. These functions are not doing anything for the moment, but they will do in the player scene. The basic character is ready. Now let's create the player scene. Create a new inherited scene from the basic character, name it player, and save it. Let's add some new nodes. Add a node called state machine. We will attach the script later. Add an area 2D node called hitbox with the collision shape 2D child. The shape of the collision shape should be at the right of the player, as far as the sword reaches. The collision layer of the area must be empty, because nothing shall collide with it, and the collision mask shall be player, since we want the hitbox to collide with other players. Let's make the player script. Create a new script for the player. Extend basic character to inherit the HP and the functions we made before. Create three constants. An integer called gravity with the value of 200. A float called friction with the value of 0.1. You can change it, but it must be a value between 0 and 1, where 1 is the maximum friction and 0 is no friction. A float called acceleration with the value of 0.25. Like the friction, his value must be between 0 and 1. Now, let's add some variables. An integer called speed that contains the speed of the player. A float called dir that will contain the horizontal direction of the player. His value must be between -1 and 1. An integer called jump impulse that stores a value we will add to the velocity when the player presses the jump button. And finally, a vector 2 called velocity that stores the current velocity of the player. When the player dies, we don't want him to move, so create a Boolean variable called canMove to control whether the player can move or not. Initialize it to true, since we want the player to be able to move when we spawn him. Add a setter to the variable. Now create the setter function. Inside the function, assign the new value to the canMove variable. If canMove is false now, set the direction to 0 to make sure the player does not move in any direction when it's killed. Let's add the necessary onReady variables. One for the state machine, another one for the animation player, and the last one for the hitbox collision shape 2D. Now that we have a variable representing the hitbox collisions, we can disable or enable it when the enable hitbox and disable hitbox functions are called. So override these two functions and change the disabled property of the collisions accordingly. To flip the player in the horizontal axis, create a new function called flip. Inside the function, change the flip edge property of the sprite to the contrary value that has now. If it was facing the right, it will face the left, and if it was facing the left, it will face the right. But there's something else we have to change to. The hitbox collision is facing the right, If the player changes the face direction, the hitbox collision should face that direction too. To do it, just multiply the x position by -1. Let's create a function to get the input from the player. Name it getInput. First of all, get the direction in the x-axis using the getAxis function and store it in the dir variable. If the direction is not 0, check if the direction is greater than 0 and the player is facing the left, or if the direction is less than 0 and the player is facing the right. If so, call the flip function to flip the player. In case the direction is not 0, we also want to increase the velocity in that direction. I use the lerp function to increase the velocity smoothly until it reaches the speed specified in the speed variable. After this, check if the player has pressed the jump button. If so, set the I component of the velocity to the jump impulse variable. You can create an input action to detect when the player jumps, or you can just use the UIUp action to make it jump when the up arrow is pressed. In my case, I will create a new action to jump. Open Project Settings, Input Map, and add a new action called UIJump. Add the space or whatever key or case do you want in the input action. Note that we are here, create the UI attack input action too. I use the 0K. Choose whatever you want. Back at the player script, create the physics process function. If the player can move, get his input. Next, apply the gravity. Add the gravity constant, multiply it by delta to the I component of the velocity. Move the player using the move and slide function with the velocity. Pass vector2.up as the second argument to indicate the up direction. Finally, if the dir variable is 0, apply the friction interpolating the velocity with rep to 0 using the friction constant. I forgot to check if the player is in the floor before applying the jump impulse, so check it with the isOnFloor function. Godot can detect if the player is on the floor thanks to the vector2.up value we passed in the move and slide function. Let's test the movement. Open the game scene and instance the player scene. Play the scene and the player falls down. Let's check the collisions. I actually enabled the player collision instead of the wall collision in the base character scene, but it still does not work. I found the problem. Even though I changed the collisions of the base character, the instance of the player has not updated them. So if you had the same problem, just change the collision of the player instance. Play the game. It works now. Try to move around. Feel free to modify the constants and the variables to adapt the movement as you want. The player also flips correctly when the direction changes. That's it for this tutorial. In the next one, we are going to implement the state machine and the hitbox. Meanwhile, you can try to add platforms to the game. I already did a video about it, so I'm not going to repeat the same. Or you could try to implement the state machine yourself. The best way to learn is through practice. I hope you liked the video, and see you in the next one.